How could we teach a computer to either walk by itself or cook or even drive on its own? To answer that question, I'm doing first machine learning project, which is teaching a machine learning model how to drive by itself in trackmania. Well, first of all, how could we teach it? Well, there are three ways to do that. Supervised learning, which is like giving the computer pictures of the data or the thing we want to teach it and putting a name on it. For example, we have a blue pen, okay? So we would give it a picture of the blue pen and tell it, this is a blue pen. And another thing is, if I flip the pen like this, it may not recognize it. If I lean the top like this, it may not recognize it, but this is a pen. That's why supervised learning needs a lot of data. Because computers, even though they are small, they are not as smart as recognizing the objects like humans. And the other way unsupervised learning is also giving it the data of pictures of the thing I want to teach it, but this time without labels. But using classification, it will be able to detect the similarities between objects. It will be able to detect that by its own. Then thirdly, which I'm going to be using today, is reinforcement learning. What reinforcement learning is? It's basically having an actor for an agent and having an environment. In our case here, it's the call, the actor. The call would send an action to the environment, and the environment would send back a feedback. And in the middle, there was a policy which would determine if this behavior or the action sent by the call is good for all or not. In this case, our goal is to finish the track as fast as possible. So how does the policy know it's doing a good behavior or a bad behavior? Well, this is where a fitness function comes in. It's basically like a point system where, for example, if the call makes it past the checkpoint at a new record time, it will give it points. But if the call keeps crashing and sticking to the wall, it would take points from it. In the end, from how many points it has, it will be able to determine its performance. So we have got a fitness function which could determine our performance. But there needs to be a mind, the mind that would take the actions for us and show us the outputs. What does that is a neural network. And a neural network is simply a function. Yes, the thing we took in school, that easy topic, that's what a neural network is because it takes in an input, processes it in the function, and then spits out an output, like how a function works. So it's fascinating how something as complex as that is based on something as simple. So basically, almost everything that you could put into a function could be solved by a computer. Anyways, what does the neural network consist of? It consists of input layer, an input layer where it takes in the input, a hidden layer or like the middle layer where it would process it, and the output layer. And in my case, I had 12 nodes, which means 12 inputs of the distances. And the output, I took in 3 outputs, moving forward, right and left. How does it process the data? Or what does the middle layer do? When every input node is connected to a node in the middle using a connector. The connector would have its own weight, and the node it's connected to has a bias. So we take in the input, we multiply it by the weight, then add the bias, and we keep repeating that every layer it passes through till it reaches the output. But what sets the weights and biases in the neural network, and how does the middle layer look in general? Is there a specified number that we need to put? Well, no. This is why I used a genetic algorithm, or specifically NEAT. A genetic algorithm is like a simulation to evolution, literally. It would have random neural networks. For example, we have 80 cores. Each core has its neural network with its random weights and random biases. Then the core would go through the track and calculate its performance. After getting its performance, we would see who are the, for example, the top 20 cars, and when it comes to performance, we would take these cars and breed them together to make the next generation. But how do we breed them together? We would take the first car and have the second car both have its own genomes. We, for example, would take a piece out of the first core and put in a piece in from the second core, making a new offspring, having a new neural network. We will keep doing that until this process will keep repeating until we find a core that is suitable for us and makes it put it back in the timing we want. So it's basically natural selection. It doesn't only work in bio, it also works here in computers. So by natural selection, we would get the best neural network which could work for us. Let's get into my part. How did I do it? Well, first of all, I needed to get a set of inputs to feed the algorithm. I had to get the distance, but there was a problem. I couldn't get access to the API of the game. So it gave me a headache trying to get these data. So I had to get creative, and what I did is I used OpenCV to capture the screen. Then I would make it highlight the edges. What I wanted to do is only highlight the walls, meaning that's the edge. And 15 rays would come out from the center going upwards. Then I would get the intersection point between the ray and the edge, meaning the point of the wall. Okay, and calculating the distance. But the problem is it was really inaccurate. The flow itself was detected as an edge because of the wrong design. So I had to change that rate. Another way was that the track is mostly like the edges of the track is back. So I kept the rays and made it that so it comes out from the origin and extends forward till it reaches the first black pixel in its way. Then I would get the legs of the ray, and that would be the distance. Another thing I got also was using the image capture is the checkpoint. So I could determine the performance of the car, how many checkpoints it got through. But the problem with this, computers, as I said in the beginning of the menu, cannot detect objects, so cannot detect numbers as easily as humans do. They just see it as pixels. So I got a pre-trained model from the internet and using TensorFlow, and passed the image of the checkpoint to it, and it would give me back the number of what checkpoint is on. So that's how I got the checkpoint. I could have done the same thing for speed, but the reason I didn't get the speed and put it in the inputs is because it would keep changing rapidly, and so basically it had a hard time detecting what the numbers are, and also my computer was already having a hard time doing all of this, so I just kept it like this. So after getting the inputs, I would just pass it into the algorithm and I would let it do its work. So was it that simple? No, not at all. Okay, it's really going bad. It's chaos. I needed to fix two things. First of all, it's sticking beside the wall. I only put a fitness function where it would depend on the checkpoint and how fast it would go past through it. I thought it would just figure it out that it needs to not crash so it could go as fast as possible. So I just added a function for that where it would take points from it if it just sticks to the wall. The other problem, it going in donuts. The problem was that I had a function where it would give it points whenever it doesn't crash to the wall and it keeps moving forward. So what it did, it just kept moving in circles because it wouldn't crash and it would get points. So it thought that was a good behavior. So anyways, after fixing these tools, I started training again. So after fixing these problems, I still had some trouble with the algorithm itself. I had to tune it a bit and play here and there with it so I could figure it out. But in the end, I should have just read the documentation because it really helped. Anyways, I have trained the model for 6 hours today, and it's not the best, as it still crashes a bit, but it have learned some driving skills, and this is what I'm going to end the video with today. I'm going to keep some clips in the end of how it drives around the track, and this is it. I really had fun doing this project, and I hope I explained it well. I'm probably going to do a part 2 when the model learns to drive more, or like I'll let it train more. But yeah, see you in part 2, I guess.